Right, so look at this question first of all. Have you spotted what sort of question it is?
Well, it looks like a moments question.
Right, so can you remind us what we mean by moment?
Moment is the turning effect of a force.
Right, and what's the equation for calculating it?
The equation is force times distance from the pivot.
Okay, right, now look at this question where you've got several forces, so there's several moments, and it says that the system's in equilibrium. So what can you tell me about the principle of moments? What does that say about systems that are equilibrium?
Well, it means that the total clockwise moments must equal the total anti-clockwise moments.
Okay, so you have a go at solving the question then?
First, we need to find out where we're going to be taking the moments from. So I think a good place to take the moments from would be the middle, the pivot. So, we would have to write down, take moments about the pivot. So now we have our pivot, we need to find out the weight.
So can you write the equation down to begin with?
Yep, it's total clockwise moments equals total anti-clockwise moments.
So look at the different forces on the diagram. Which of those forces provides a clockwise moment?
The weight provides a clockwise moment.
Okay, so can you write down the expression then for the clockwise moment?
It'll be weight times by the 2 metres, because going back to force times distance about the pivot, it'd be 2 metres from the pivot. So it'd be weight times by 2.
Right, that's the clockwise moment.
That's the clockwise
Are
moment.
there any other forces with clockwise moments?
There aren't any now.
Okay. Right, so what's that got to be equal to then?
That would have to be equal to the anti-clockwise moment.
Yep.
Now we can see there's a lot more in the anti-clockwise moment than there is in the clockwise. So, we'll begin with the 25 newtons. So, that would be 25 times by 2 metres from the pivot.
And then there's another one to add on.
Yep. So we'd also have to add the 10 newtons on, and also the distance from that, which is 1 metre. And then we should have enough to work out the equation. So it'd be 2 times by W, which would equal 50 plus 10. So 2 times the weight would equal 60. So we've got 2 times the weight would equal 60. Therefore, weight would equal 60 divided by 2. So the weight would equal 30 newtons.
So now we've added a bit more to the question. It says if the weight of the beam is 5 newtons, calculate the size of the upward force provided by the support. So before we do this bit, there's one thing that we should mention, is that in the first part of the question, we didn't have to worry about what the weight of the beam was. How come that didn't make any difference?
Well, because we were taking moments from the middle of the beam, and that would mean that the moments would equal 0.
The moment of the weight?
Yeah, the moment of the weight would equal 0.
Okay. Right, so have I got this one then now?
We know that the weight equals 30 newtons, and we also know that the weight of the beam equals 5 newtons, the pivot. The total downwards force would equal 25 plus 10 plus 5 and plus 30. Now all of that would equal 70 newtons. Now, for the beam to be in equilibrium, that would mean that the upwards force provided by the support would have to equal 70 newtons for it to be the same. So the upwards force would have to equal 70 newtons.